Today we talked about greatest common factor, or GCF. So we had done application, the first one together. We're going to go back over. Miguel collects insects. He has 18 grasshoppers. That's important, so we're going to circle it or underline it. 9 crickets. That's important. And 21 ladybugs. That's also important. For a science project, he will display an equal number of each kind of insect in a jar. What is the greatest number of jars Miguel can make? Greatest number is going to be our keyword for GCF. So I put that over here in our keyword area. Greatest, it's not working. Greatest number is what that's supposed to say. So to find greatest common factor, we have to find the factors of the 3 numbers they give us. So I have 18, 9, and 21. If I know all the factors, I can go ahead and list them. If I do not, there's another way to find them. If we take our number and we use prime factorization. Prime factorization, remember, is break it down into prime numbers. So I'm going to break this down. 2 times 9 is 18. 2 is prime. Break down 9 with 3 times 3. Those are both prime. So my prime factorization is 2 times 3 times 3. How that helps us with the T-chart, we always start out with 1. 1 times 18 is 18. The prime factorization helps because we have a 2. If we see a 2, it means that 18 has a factor of 2. Next, cover up your 2. What do you have left? I have a 3 and a 3. Well, 3 times 3 is 9. That means 2 times 9 is 18. Next, I'm looking for 3. I see a 3. That means that 3 is a factor of 18. So here's my 3. Cover the 3 up. What do you see left? I see a 3 and a 2. Multiply the 2 together. 3 times 2 is 6. That means 3 times 6 is 18. Do you see a 4, or can you multiply anything together to get 4? No. 5, no. 6, I don't have a 6, but I can multiply 3 and 2 together. But notice what's happening. If I have a 6, it's going to be 6 times 3. I already have that. So that's starting to repeat. I just draw an arrow to show the numbers are repeating. I go to 9. You can probably do 9 without this, but I'll just show it to you again. I'm going to break them down. Prime numbers are 3. My prime factorization of 9 is 3 times 3. I always start off with my 1. I know the factors of 9 are 1 and 9. I look at my prime factorization here. I do not see a 2. So that means 2 is not a factor of 9. I do see a 3. So I know 3 is a factor of 9. And what do I see left? 3. That tells me 3 times 3 is 9. Notice my numbers are the same. So I'm repeating. I'll draw the arrow and move on. 21. Oh, sorry, factors. 21 is 3 and 7. They're both prime, so prime factorization is 3 times 7. For 21, I start with 1. 1 times 21. I look at prime factorization. I do not see a 2, so 2 is not a factor of 21. I do see a 3, so 3 is a factor of 21. What do I see left? 7. That means 3 times 7 is 21. If I go back through 4, 5, 6, I don't see those, but I do see 7. But that starts to repeat again, so I'm just going to draw my arrow. Now remember, I'm looking for greatest common factors. So the first thing I'm going to do is look for common factors. Common means they're the same in all 3 of my numbers. So I look. I'm going to start with the first one, 1. Do I have a 1 in all 3? Yes, so I'm going to circle them. Next, I look at my 2. Do I have a 2 in all of them? No, so I'm not going to circle. Next is 3. Do I have a 3 in all? Yes, so circle. And I'm going to go to the other side. Don't ignore the other side. Do I have a 6 in all? No. 9, not in all. 18, not in all. So what that means is my common factors, or the factors that all 3 share, are 1 and 3. But my question asked for the greatest common factor. Well, what's greater, the 1 or the 3? The 3 is greater, so my greatest common factor for GCF is 3. Okay, let's go to number 2. Pause the video, try it on your own, and then come back and check with me. Okay, so you should check this on your own. Rosie was making button necklaces. She had 20 yellow, so I'm circling what's important, and 12 orange buttons, circling what's important. You should have started with a T-chart. Let's see, we're greatest number. They use the same important words here. Okay, so T-chart for 20, T-chart for 12. If you're not sure of your factors, break them down to prime factorization. For 20, I have 2 times 2 times 5, but I'm always going to start with 1 times 20. I look and I see a 2, that means 2 is a factor. 2 times 5 is 10, so 2 times 10 is 20. Do I see a 3? No. Do I see a 4? No, but 2 times 2 is 4. So I can make a 4, cover those 2 up, and that just leaves me with the 5. And 4 times 5 is 20. Then I look for a 5, and I have it, but my numbers repeat. So I'm going to draw my arrow to show repeating. Do the same thing for 12. 12 is 2 and 6. 2 is prime. 6 is 2 and 3. Prime factorization, 2 times 2 times 3. Start off, T-chart, factors 1 and 12. 2, yes, I see a 2. It's a factor. Multiply the ones left is 6. Go back, I see a 3. Cover it up. I have 2 times 2 uncovered, meaning 3 times 4 gives me 12. Again, my numbers are about to repeat, so I stop. Common factors, circle them. They both have a 1. They both have a 2. They both have a 4. They do not both have a 5, a 10, or a 20. So my common factors are 1, 2, and 4. My greatest common factor is 4. Okay, let's move on to the Venn diagrams. Let's open up our file. Venn diagrams. Find the GCF. We're going to start with your prime factorization for 24. Break them down until you have all prime numbers. Two times 2 times 2 times 3. That's for 24. Then let's do the same for 36. 6 times 6, neither are prime. 2 times 3. 2 times 3. Prime factorization for 36 is 2 times 3 times 2 times 3. So what I'm looking for are pairs of numbers between 24 and 36. They have a pair of 2's, so in the middle I'm going to say they have one pair of 2's. They share. I see another pair of 2's, so I'm going to write another 2 in the middle. Then I see they have a pair of 3's, so I'm going to write the 3 in the middle. Now 24 has a leftover here that doesn't have a pair, so I'm just going to put it in the side. 36 has a leftover 3. I'll put that over here in that side. For GCF, we do not worry about the sides. We're only focused in the middle. In the middle, I see 2 times 2 times 3 to give my answer. 2 times 2 is 4. 4 times 3 is 12. So the GCF is 12. Same thing over here with 4 and 20. 4 is easy to break down. It's just 2 and 2. So for 4, I've got prime factorization of 2 times 2. For 20, I have 2 and 10. 10 is 2 and 5. I separate those and run out of room. So for 20, prime factorization is 2 times 2 times 5. We're going going to find the ones that are the same. So we've got a pair of 2's, that goes in the middle. A pair of 2's, that goes in the middle. 4 has nothing left over, but 5 does. We're going to put it over on the side. GCF, we are only going to worry about the middle, not worry about either one of these. What I see in the middle is 2 and 2. We're going to multiply them. 2 times 2 is 4. So the greatest common factor would be 4.